In this lesson, we'll use the first order integrated rate law to determine the concentration of a reactant at a given time. The first of two questions reads, let's say that you've determined that the decomposition of SO2Cl2 is a first order reaction and has a rate constant of 2.90 times 10 to the power of negative 4. The decomposition formula is shown here. If the reaction is carried out at the same temperature and the initial concentration of this molecule is shown right here, 0.0225 molars, what is the concentration after 865 seconds? To do this, we'll be using the formula known as the first order integrated rate law. Notice that we are using a mathematical function known as ln. That's when you have log with the base e. Let's write down everything we know. We've been given the constant k, and that's equal to 2.90 times 10 to the power of negative 4. It has the units of 1 over s. We've also been given the concentration right here, where the concentration of this molecule is equal to 0.0225 molars. The time is provided as 865. All we have to do is substitute this information into this formula. Now we've been given the initial concentration, and that's represented as ln the square brackets, our molecule represented as A, subscript 0. That's your initial concentration. Let's go ahead now and substitute the information. We're looking for ln of, we'll just call this A for simplicity. A subscript T is equal to negative this number, negative 2.90 times 10 to the power of negative 4, times the time, which was 865, plus ln of our concentration given in the question, 0.0225. And I'll write the subscript 0. I haven't written down the units, but over here we would have 1 over s, and over here we would have s. The s units would cancel out, leaving us with a unitless number. Therefore, the only unit that would be remaining is the one here, which is in molars. I'm going to go ahead and use my calculator. I have negative, starting over here, 2.90 times 10 to the power of negative 4, multiply to 865. Let's continue. Plus ln, that button, 0.0225. The right side of this equation is equal to negative 4.045. On the left side, we have ln of our final concentration. To get rid of this function ln, you actually have to raise both sides of this equation to the base e. So if I raise this side to the base e and this side to the base e, this ln and this e will cancel out, leaving us with A exposed, the concentration of A. Now, you can type in alpha, E, and then raise that to the number that we found. Notice I'm not rewriting it, I'm just pressing answer. This gives us 0.0175. And to 3 significant figures, since this number was 3 significant figures, we can write down 0.0175. 0.0175, and writing this in scientific notation, 1.75 times 10 to the power of negative 2 molars. That's the answer to question number 1. If you'd like to see the solution to question number 2, make sure you watch question 2 of this series. We'll see you soon.